Okay, so there's like 5 different exponent rules, if you'll recall, that we talked about that we're gonna be learning in this unit. Chapter 6 is a lot about just some polynomial things that we have to really kind of understand to do the inverse of it when we get to chapter 7, which is your next unit. I pulled those units apart. Used to, it was one big unit, it was a lot of content. So this unit might seem a little bit shorter and smaller, but I want to make sure we really learn this and focus on it. Maybe spend a little extra time on it than what we have been able to do in the past. So our multiplication property of exponents, they call it the product rule. You're not multiplying the exponents. It's kind of misleading. It just means that when you're multiplying two like bases, we're going to be adding their exponents. Okay, so kind of did an example like that the other day that I didn't record. Remember, like if you had x to the third times x squared, if we were to expand that, that'd be like saying I have 3 x's to represent that x to the third, and then I have 2 x's to represent the squared. And so really there's 5 of them there. Instead of doing that, we can just add their exponents. So in this unit, you really need to be thinking about a lot of the math is actually happening up in the exponent part of the problem. I always call it the exponent world. So if you look at number 1, if you don't see an exponent, that would be like saying an understood 1, maybe a different colored pen. But my letter A, I would be adding 1 plus 7. Because those are the exponents for those letters, and for B, you'd be adding 3 plus 2. So you get A to the 8th and B to the 5th. I'm aware you can do mental math and add 1 plus 7 and 3 plus 2 on your own, but because of all the different rules, you need to know the difference when you add and multiply and subtract. Go ahead and write it down in your notes. I encourage you to do that anyways. So remember, the reason we know to do that is because I'm taking this term times this term. So there's nothing separating them, right? And that indicates multiplication of those variables. So we just want to see 1a and 1b in the end in our solution. Sometimes you will have numbers out in front that actually get to be multiplied. You know, like that -4 times 3. So multiplication really does happen when it's a coefficient or the numbers in front of those letters. So -4 times 3 is a -12, and for x, you're adding 5 plus an understood 1, so I'll just go ahead and write it. And for y, you're adding 3 plus 2, so you have -12, x to the 6th, y to the 5th. Okay, so that's when you add exponents. Sometimes we're gonna have to do more than one operation, but we have to learn about the second operation. Remember, these rules seem really easy when they're broken down, but we need to make sure we really understand each one separately. That way, when we put it together, we know what to do. Okay. Here it says rule for simplifying powers of products. So when we have a parentheses and it's raised to power, like for instance, this is kind of like saying we have 3 set because of this exponent of 2a to the 3rd, b to the 4th. So that means you'd have to write that 3 times and then do what we did above. So kind of squeezed it in there. Well, instead of doing that, we can just multiply exponents. You're not raising the exponent to another exponent. You're just multiplying. And please remember that numbers are just like letters. If you don't see an exponent like on 2, it has an understood 1. So like that little shiny right there. There we go. So you are multiplying something for that, the coefficient part too. There's stuff happening with it. It doesn't just happen with letters. It happens with all the things. So here we have a parentheses raised to the 4th power. So we're taking x, 3, and then you're multiplying that 3 times a 4. And then for y, 2, it also gets multiplied times 4. I know you can do mental math and take 3 times 4. I know that's x to the 12th. It's good to just write it down so you remember that's when we multiplied. It's easy to see that. instead of trying to figure out how did I get 12. So 3 times 4 is 12 and 2 times 4 is 8. But just kind of like example 2 above, sometimes you have coefficients in there, right? That one just had letters. Coefficients have understood ones, just like this x has an understood one exponent. So if you need to put that in there to see that it has an understood one that we sometimes can forget about, please do. So you have -5. And since there's a negative, I like to keep it in a parentheses, so it helps keep sign straight when that is raised to like a positive or an even number, I guess. I'll say positive number. If that was raised to an even number, you know, it would make it a positive. But I'm taking 1 times 3. And for x, I'm taking 1 times 3. For y, its exponent is a 4. It gets multiplied times 3. And z 3 times 3. So I use dots that time instead of parentheses, however you want to write it, it doesn't really matter, but this would be like saying -5 to the 3rd power, x to the 3rd, y to the 12th, and z to the 9th. So when you get to your last step, if you have a number and you know there's nothing else you can do with exponents, that's when we're going to want to start simplifying and saying, tell me what -5 to the 3rd power is. And remember, if you plug it to your calculator, since this is an odd exponent, it wouldn't matter as much, but try to be in the habit of plugging in the negative with the parentheses. That's going to be a negative either way, like I said, but if that was like to the 4th, let's just say, what if it was to the 4th power and an even exponent, kind of going over those sign rules, then it would be a positive. But if you don't use that parentheses, I've talked about this since unit 1, it seems like it reads it as the opposite of. So that's why the parentheses is an important part of entering it into your calculator. So anyways, just a reminder of those weird things, because that's where sign errors can happen, making it seem like you don't understand what you're doing, but maybe you just made a sign error. So the 2 things that you learned on this first page were when you add exponents, that's when you're taking something times something, or a like base times a like base, right? We talk about exponents. This is called a base. Then you add their exponents here. If you have a parentheses raised to the power, we're going to multiply those exponents. So like 3 times 4. Turn the page, and we're going to learn another rule. Definition of a negative exponent. I kind of go back and forth. Sometimes I want to teach the division property first, and sometimes I want to teach the negative exponent thing first. But basically what happens and what can make a negative exponent happen is if you had a squared over a to the 3rd. The old way of simplifying this was like maybe writing it all out, right? And then we can cancel this stuff out. Guys, please remember to put your devices up, and I want you to be taking notes. So see how you could, 2 of those would like cancel out, and you would be left with 1 there in the bottom part of that fraction. So this would be like saying 1 over a. When we learn the division property, it's kind of like you're taking 2 minus 3, which gives you a to the -1. Well, negative exponents are not proper, I guess would be the way to say that. And so we fix negative exponents by always thinking of everything we have having a numerator and then denominator, even if you don't see it. And so to fix a negative exponent, what we could do is just kick it down to the bottom and it makes it positive. So you kind of learn these 2 things almost together, but it is separate. So I introduced that to you, but let's go look at just the negative exponent thing, and then I'll talk to you about the subtracting exponent thing. That's 2 separate things, okay? So anytime we have x raised to some negative power, if that's all that you see there, then you just shift it to the bottom and you have to put the 1 on top of it to show it as a fraction, right? You have to have something up there. If that was like 2 to the -4, It doesn't make that a negative number, it makes it a fraction. So we would think of it like as moving 2 to the 4th down here, then simplifying, that's the number 16. So this is why the other day when we were doing some extra examples before we started lecture, just to introduce it to you, that I said it's really important for you to work with the exponents first, even with like the numbers 2, you might be subtracting some exponents because negative exponents can pop up. Did you remember me saying that a little bit? If the negative exponent's in the bottom, you just shift it up to the top, it makes it a positive exponent, like it fixed it. And that's now like 5 to the 3rd. Since there's nothing else in the bottom, we just leave it there and they simplify. 5 to the 3rd is 125. So negative exponents never make a negative number. They just can make a fraction. Is what I hope you get from that. So here in example 5, the only thing that is a negative exponent is the a, right? A to the negative 3rd. The 6 doesn't have a negative exponent. So if you were to just fix that, you would say 6 over a to the 3rd. That's all you have to do on that one. There's nothing else to simplify or reduce or anything. Just a over 6 over a to the 3rd. Down here, we really just have a negative exponent here. It's almost like trying to fix the things that are red flags in a problem that you can't answer it like that. You can't answer something with a negative exponent. So we would just move that up here. And since there's an understood 1 there, we would just write d to the 8 over 6. I think that was C that was really excited. The reason we don't have to write a 1 is because when you have a letter there now, it didn't have a letter there before, right? When you have a letter there, it then begins to be like it's understood. There's not a letter there, you have to have the 1 there. Because that's not understood. So combining kind of all the 3 rules that you've learned so far in number 7, if you have a parentheses raised to some power, and do you see that you have positive and negatives? The steps that you're going to take is first, multiply your exponents. Like this, it's multiplied times 3. So let's go do that. So here we're taking 2, and I don't generally show the multiplication step, but I will show the addition step. So 1 times 3 is 3. For A, you're working with negative numbers now. So negative 3 times 3 is a negative 9. And B, 2 times 3 is 6. I keep that in parentheses. My second parentheses is being raised to what power? That one's being raised to a negative 4. So we have 2. 1 times negative 4 is negative 4. For A, it's like as an understood 1. 1 times negative 4 is negative 4. For B, negative 1 times negative 4 is now a positive 4. So now we have to start thinking about negative stuff. So remember back on that page before, we learned when you raise something to a power, we multiply their exponents. And then we also learned when you get to something like that, then we start to add their exponents, right? So sometimes you have to kind of think about order of operations and apply it a little bit to your exponents, but you always multiply or divide before you ever added or subtracted, right? So think about that with the exponents. If you ever have a parentheses raised to power, we know we have to take care of that first. Because what this is representing is like there's 3 sets of this. So what is this really? So that's why you need to make sure you do that multiplication step first with your exponents. Then add, and I say that with quotations because now we're working with different signs, aren't we? So isn't the number 2 the same base? Right? Like kind of like the letter A. So this is the whole reason I say if you have the same base, don't try to simplify that 2 to the 3rd to the 8th first. Don't try to simplify that 2 to the negative 4th, because that's where mistakes are going to happen. That makes a fraction. This one would, if you did. The easier thing to do is to wait and understand that they're the same base. And we're taking 3 plus a negative 4. Remember, we're adding exponents, but it's really like saying combining, because you have to decide if you're really adding or subtracting according to their signs. A, you have -9 plus -4. And B, 6 plus 4. So what we have is 2 to the negative first power, A to the negative 13th power, and B to the 10th. So we work this problem in the exact order that we learned. I say the exact order, not really, not the exact order. We work this problem with our multiplication to get rid of the parentheses power. Then we can add them, which was the first rule we learned. But then we fix negative exponents in the end. Okay, we don't want to fix those negative exponents until we've done all the getting rid of the ugly parentheses, and we only see AB once. So this has a negative exponent, and so does this, right? So what that means is, think about like this is all over 1. We need to move those to the bottom part of the fraction to simplify it. So b to the 10th, isn't that a positive exponent? We will just keep that in the top. And then we would move 2, and I don't need to put the understood 1 there. It just makes it a positive when you shift it down. And a to the 13th. I do have to put the 13 on it. I didn't put my 10, did I? B to the 10th stays up top. And then we move our 2 to the understood 1 and A to the 13th to the bottom, and it makes it a positive exponent. Sometimes these rules start to just really collide, and you have to do 2 or 3 different things to simplify a polynomial that you're given. The whole goal is to only see ABC one time in the problem, if any. If it's A, B's, and C's. So the reason I teach you about the negative exponent rule before the division property is because technically in the division property, you're subtracting exponents in this one. Which can show up as a negative exponent sometimes. I don't generally do it all up in the top and then make it another step to fix the negative exponent. I'm going to show you how some instructors will teach it if you ever see it past me. But like if I were subtracting, think about your fraction line to help you remember that you're subtracting exponents maybe. Kind of looks like a big minus sign. So for A, you would be taking 3 minus 5, so top to bottom. For B, you're taking 2 minus an understood 1. And for C, you're taking 6 minus 4. So this would give you A to the negative 2nd, B to the understood 1 power, and C to the 2nd power. So what we just learned, can I call that my answer? No, because I have this negative exponent. So what we just learned was, if that's the case, I would have to keep B and C squared up top and just move A squared to the bottom. And for the most part, you can do it always like that if you like. There's some sign errors that can happen when we're subtracting a negative, because we do that. Sometimes we're subtracting a negative. But I like to just say it's a lot easier and faster, and it seems like you have one less step. If you just identify where the bigger exponent is, subtract those numbers and leave it where the bigger one is. So like, where's the bigger exponent for A? Is it in the bottom? So I could just say 5 minus 3 is A squared. Where's the bigger exponent for B? In the top, so I could just say 2 minus 1 is B to the understood 1 up top. And C, the bigger exponent is on top. So 6 minus 4 is 2. So isn't that the exact same thing? That's actually how I do it. I did take you through what is the technical concept of subtracting exponents. And you can do it either way, it doesn't really matter. Some people might really like writing that minus step out and then fixing the negative in the end. It gets a little hairy when you are given negative exponents in your problem, but I'll show you what I do in that case that's different. So this problem didn't have any coefficients, but this one did, or does. So it's not like you're working with exponents on that, right? You just reduce it like you would any normal fraction if you didn't have x's and y's in the problem. So when you have coefficients up here, which I'll just kind of box it out to draw attention to it, you just reduce this like you would any normal fraction. So -4 and 16, they both could be divided by 4, so you could say like a -1/4. Just reduce the number parts, then start to do your subtracting steps. Where's the bigger exponent for x? It's up here at the top. I like to circle it because it just draws attention to it. So 4 minus 2 means I'll have x squared left up in the top. Where's my bigger exponent for y? The bottom, so I'm subtracting 3 minus an understood 1 to get a y squared. And the only thing about this is WebAssign doesn't like understood 1s. Do you see an understood 1 now? When I reduced that 4 and 1, I really couldn't write that down when you type it in. It's not wrong in my opinion if you did, but WebAssign doesn't program it that way. So you would just call this a negative term. You have x squared over 4y squared. So if you have a letter that ends up staying up there, you don't put the 1 with it. If it's a number 2, you would put a 2 with it, right? Because that's not understood. So it's okay to have negatives out in front of numbers. Hopefully you kind of recognize that. That's just like saying I have this negative fraction. Let's forget about x's and y's. That's -1/4. Okay. So you can have a negative fraction. We can't have negative exponents. So over here we have a kind of a lot going on. First of all, we could reduce this -28/42. Remember your calculator can do that as well for you. If you don't notice what number can go into the both. I think it's 14 goes into both of them, right? You can 7 will, but then I think it reduces a little bit more. So you can plug that in and say -28/42 is -2/3. So if you reduced it by 7, that would be fine. You just have to reduce it again by dividing by 2. So this would reduce down to a -2/3. So like I said, if you reduce by 7, somebody said 7, which is just fine. That would be 28 divided by 7 is 4, right? I just like blanked out for a minute. And then you'd be like, oh yeah, those can reduce again by 2. So just make sure you get it reduced down to its lowest. Because you have negative exponents in this one, you could do your subtract step if you want, like we did in example 8 when we were learning it. Or I leave my positive exponents where they're at. So it'd be like d to the 5th and c squared. Those were the 2 things that had positive exponents. But then what I do is move my negative exponents to where they would go if I were fixing it at the end. So like I would move a c to the 4th down here, and that makes it a positive, and then d to the 3rd up here, and that makes it positive after that. And then what do you think I could do so I don't see d's and c's twice? Do you have an idea? Is that like multiplying when they're by each other? Yes. So when you get there, then you would just add those exponents together. So that would be like We'd just be adding those things together, if you want to go like that. So D to the 8 and C to the 6. First two rules seem black and white, but when you put them all together, that can be, it can seem a little hairy. So you just have to know where to start, what to look for, when to move a negative exponent, or when you can move it. I almost always wouldn't move a negative exponent until the end. This was like almost to the end. There wasn't any other operation happening. Like it wasn't raising it to power or anything. Let's see lots of extra examples, where you'll get to practice lots of different ones like that too. Our last rule that we learned with exponents, kind of a weird rule, but when you raise anything to the 0 power, that means it's the number 1. Why is that? Why would we ever have to know that? Because if you're working up in the exponent rule, things can zero out, right? If you were subtracting, like if you had 2 to the 5th over 2 to the 5th, you already see that that could divide up into itself 1 whole time. Be like, we already know that's 1. Even if we didn't know what 2 to the 5th was, which 2 to the 5th is 32. If you simplified it, you could see that it's the number 32 and it becomes the number 1. But if you were more doing it with the subtracting step of our exponents that we just learned, our division property, we would be taking 5 minus 5, which gave you 2 to the 0 power. So we can't ever answer something with 2 to the 0 power. We just need to know that that becomes the number 1. Okay, so, oops. Just be careful what you're saying is being raised to the 0 power, because you may have to actually do a step. Just because something's being raised to the 0 power doesn't mean the answer is 1. So we would be taking -7 times x to the 0 power is a 1. So you have another operation before you answer that finish. We would say that our answer is a -7. So you don't have a variable in your answer at all when it zeroes out. Or at least not that very. If we take a parentheses and raise it to a power, remember, what would we be doing with 0? With the exponents? Multiplying. So this would be like saying 1 times 0 is 0. Times x is a 1 times 0, which is 0. So don't both of those this time become a 1? So be careful when it's being raised to the 0 power in a parentheses and when it's not. So this is like saying this is the number 1 times 1. So my answer did end up being 1 on that one, but it doesn't always happen like that. Those are those 5 rules, and I have kind of a quick review at the bottom of this sheet that we go through just to kind of recap them all. Now these don't combine other rules with them. We'll do some more of those. Maybe here in just a minute, if I can pull up a couple, I'll just make up a couple of examples and we'll practice a few of these before we're done today. But I tell you what you're doing. If you're taking something times something, none of that's being raised to a power. We know that we're adding exponents. But what do I do with my 9 and my -3? We multiply it, yeah, because a parentheses by parentheses means multiply, but in the exponent world, you're adding their exponents. So this would be a -27. And for x, you're taking 1 plus 4. And for y, you're taking 4 plus 4. So visually, you gotta kind of pay attention to what it looks like when you're adding exponents. When we multiply exponents, that's when you're raising a parentheses to a power. Remember, if something's being raised to a power, it's only to that parentheses. Only to, even though there's only one thing here, I just wanted to state that. It's only to that one parentheses. So we're taking -3, and you would be taking like a 1 times 4. So I'm writing the steps, you can see the differences at least here. For X, you're taking 2 times 4. For Y, you're taking 3 times 4. So this would be -3 to the 4, X to the 8, and Y to the 12. But in this one, you may need to have one extra step and simplify whatever -3 to the 4th is. That's representing some number right now in exponential form. So this is gonna be a positive or a negative answer if it's raised to an even power. Positive, right? So that's one thing I was trying to talk about when we were doing this earlier. If you don't know 3 to the 4th power, and if you're gonna do the negative in there, you gotta make sure it's in a parentheses, otherwise it'll read like -81, and that's where mistakes happen all the time. All the time. Oh, and then I wrote it because I was saying it. But don't always be in a hurry to simplify those numbers to the power. Because if you have 2 things and they're both -3s, remember that's when you're adding their bases or their exponents. If there's another step happening. But if it's like 2 to the 3rd over here and 3 to the 3rd over here, you would have to simplify them and then multiply. You're gonna see both of those things happen. I'll try to give you an example of one of each here in just a second. Negative exponents, just as a really basic example, I might identify that has a negative exponent, and I'm just gonna fix it. I fix it by shifting it to the other side of what would be a fraction if you put this over 1. And I think that was to the 7th, right? Kind of circled over my 7. This one also has negative exponents. Remember, you could do this 2 ways. It says we are subtracting exponents, but I almost never do it like that. I'm given a problem like this, I will kind of identify my negative exponents. And I do it this way just because I've taught this like for 12 years, and it seems like students like it this way better. But I keep my 8 to the 3rd in the bottom because it's positive, right? I move this 8 to the 1st to the bottom. Do you guys have questions in the back? Here, do you have a question? Okay, please don't whenever I'm in. So we move our 8 to the 1st down, our b squared we would move down. And then our b to the 9th we're gonna move up. And then you would just try to simplify it from there, okay? So the first thing I would do is just go ahead and write b to the 9th over. Down here, they're like letters, so I'd write a to the 4 and b squared. Is there something else I can do now that is like subtracting? Yeah, we don't want to see b more than once. So that's why I put this example on there. If you are moving it like I did in the notes earlier, you know, my bigger exponent here is the 9, so we will actually get to practice subtracting them. So 9 minus 2 is 7. This could be an example of why some students prefer to write the minus step out, like we first showed you. You would have a minus to the negative first, then you would say minus 3. B, you have -2 minus, but it's a -9. So I personally don't like to do it this way because I see all sorts of sign mistakes that happen all the time. Instead of just shifting it and then going from there. So this would be a to the -4th and b to the +7th. You get the very same thing and it's about the same amount of steps. I just think there's more room for errors with your signs. So yes.
So that one on the side that you did with all the steps, that was the and questions way to do it, or is that your way to do it?
This is the way I teach it, because a lot of times students forget, like if you say -2 minus 9, they forget that it's actually minus a -9, we get sign errors, so I do it like this would be like, how I do it.
Okay.
The more, what the concept really is set up like this,
Okay.
and so you can do it this way,
Okay.
as long as you're good with your signs.
Okay, yeah, I just wanna make sure, cause the other one's kind of.
This one,
Yeah, I kind of feel it.
yeah, and every class is different, because I'll do it this way, and then if I show them this, you're like, oh, that's way easier. Sometimes I think it's the other one that I should. I don't know. Just be careful, because if you're subtracting, you need to make sure this is our subtracting sign, and then keep your sign straight from there. Yes.
So will always be positives go on the bottom, just the negatives on the top?
Yep.
No?
No, see, that's where like those sign things come
Yeah,
on.
that's.
So it's always like, because there can be negatives on the top or the bottom. So you just move them to make them positive either direction. I know. Now, if you do it like this, yes, the negative would end up in the top and you would move it.
Right. But like on the other side, when you have to like figure out where to put like the bottom one and the top one, it's just like.
So this one, if you guys will pay attention just a minute. This one right here, I fixed the negatives first. And that's just the difference. And then I tried to clean up your A's and B's after that. I didn't apply the subtracting step yet until the very last step. That's what that was about. So you had one positive down here and it stayed positive. Then those others, I moved them to make them positive. It's how your brain works. Sometimes I know giving the freedom to think is scary because maybe we don't understand it either way. So you just gotta pick one way that works for you. So the red ones I started with are the ones that I moved. That's why I wrote it red. I fixed those negative exponents first and I just moved them to the other sides of the lines. Then I started simplifying from there.
Yeah, no, like the other ones that we did for that step, like that just gives me how like it, the other way that you showed it, and how to figure out which one's supposed to top and bottom, but that way is a lot easier to understand.
This way or this way?
That, this, no,
This way.
yeah.
Okay. Yeah, you guys can, you can write out the minus sign. I can start doing that. If it makes more sense, for sure. And it may be because of how, I showed that first. I don't know why it's different between some people and others. Okay, and then the zero power, we never want to say this is my answer, have an exponent with a zero power. It's like it's given an assigned value of 1. So this is like saying -6 times 1, which means that one would be -6. Okay, so to get extra practice, kind of put all that together. I'm gonna pull up some examples that I have. And have you write them down. Make it up. Have that blank paper. And they give you a couple to try, and then I'm gonna do them with you as examples. Okay, try those two. And if you get those two guys, those are three. You only have to do 1 through 3, and then we'll pause. I'll do them 10, do 4 through 6 in a minute. Let's look at number 1. If you didn't finish number 3 with those 3, that's okay. So there's really only one exponent rule that's happening up here. Since nothing's being raised to power, we don't see any negatives. Hopefully that was an easier one to kind of take a look at. Only one exponent rule. So what do we do with 2 and 5? Since they're 2 different numbers, we do just multiply them, right? Just multiply 2 times 5 is 10. What are we doing with our exponents here? Adding. Yeah, so I'm not going to be able to tell you this is where you add them. That's why we learn all the 5 rules, and we spent kind of a lot of time on those 2 specific rules on Friday. so that you can see the difference. So you are taking 2 plus an understood 1, and for B, 3 plus 5. So 10, A to the third and B to the 8th. We only have one A and one B in there, right? An A to the third and the B to the 8th. We don't see 2 of them. Now, number 2, it does throw in another rule that we learned. This right here is being raised to the second power, and only this one. This one's not being raised to any power, is it? So all we do first is simplify, because this is like saying I have 2 sets of this, and that's what this really should be. So we're gonna be multiplying for 3, we have 1 times 2 is 2. For A, 1 times 2 is 2. For B, 1 times 2 is 2, and C, 1 times 2 is 2. Now, I'm gonna go ahead and just rewrite. You might not have done this step, and that's okay. Are these 2 different bases? Yes, I can't just multiply 3 times 4 right now. Because this 3 squared is representing some other number now in exponential form. What is 3 squared? Heard somebody. 9. Okay, so if you want, you could probably just write a line through it, put it out front if you want. Because I'm running out of room, actually, that's what I'm gonna do. And then we can think, I'm taking 9 times 4 is what?
36.
36. Then what do I do with these letters? We add their exponents. So you'll add exponents last. 2 plus 1, 2 plus 1, and C, I'm not adding to that C, am I? There's not another C, just stays C.
Shouldn't A and B be 2 plus 2?
Yeah, I don't know why I wrote 2 plus 1, thank you. So 36, A to the 4, B to the third, and C squared.
B should be 2.
Third. 2 plus 1, right? Okay. Yeah, check me, because when you get up there, sometimes it's easy to make little mistakes. So this reads, if you can't read it, 36, A to the fourth, B to the third, C squared. But then this one just throws negatives and all the things at the same time. This is where we might have some differences in our last or second to last step. We do work with the negative exponents the way they are to start with. So for 2, we're doing all of our multiplying exponents, right? Like this one's being raised to the third power, and this one's being raised to the negative 4th power. So 2 to the third, A to the 6th, and B to the third. Did you all get that? So you're multiplying those exponents first. And here, we would have 2 to the what? Negative 4th power, A to the positive 12th power, and B to the negative 4th power. Now, here, these are the same bases, different from the one above. I had to simplify 3 squared because they are not the same bases. There's nothing to do with their exponents since they're different. But since these are 2's, don't try to take 2 to the third first. Because then a lot of people try to make this a negative 16. Really what would happen is it'd be like saying 8 over 16. If you did it that way, you'd have to reduce it. That's a lot more math than you really need to do if you just work with the exponent. So 2, we're taking 3 plus a negative 4. A, you're taking 6 plus 12. And B, you're taking 3 plus a negative 4. So that would give you 2 to the negative 1st power, A to the 18th, and B to the negative 1st. Can I answer like that? No, because this is where, I guess this one, we wouldn't have any differences on the process. It might be more over here that we do. Those are kind of red flags, so I circled them in red to try to draw attention to them. So to fix the negative exponents, you just move them down. So like A to the 18th can stay there. You can move 2 and B downstairs. And since they're both like -1s, we don't have to put understood ones, but it makes them positive and it fixes all that negative exponents. But while the rules themselves are not hard, when you apply 3 rules in one problem, it become a little icky. I mean, it's just like a lot going on and you have to remember what to do. You are gonna have a problem, I'll just put it here, like some of your web assigned, when you get to your negative exponents, you might have like 1/6a to the -7th. We didn't have one quite like that. It's just the opposite in our notes. What would I do to fix that one? I just move this up top, right? It's kind of like you get to this step and you're just fixing. Sometimes you have to move them from the bottom to the top. And so you would have a to the 7/6. So we got these other 3 problems and then we'll be done. Hopefully it kind of helps reinforce all the different things you're gonna see. I can't show everything you'll ever see, but if you understand that it's raised to a power, do that first. Then add your exponents. You understand what happens with negative exponents, then I think you'll be fine in anything you ever see. So are either of these being raised to a power?
Start to be good, because we have biology.
Oh, I didn't even know what time it was. I am so sorry. Bye, guys. You have to tell me. I thought we had 10 more minutes. Have a good day. We'll go over those 4 on Wednesday. That's probably why you're like, what is